This is Lesson 12, Proportions Indirect Measurement. In this lesson, you will learn how to use proportions to find missing links in real-world applications. Your warm-up says, would you rather drive a car at a rate of 40 kilometers per hour or drive a car at a rate of 15 meters per second? See if you can figure out what might be better. How tall is your school building? You could find the answer to this question by climbing a ladder and measuring the building with a tape measure, but there is an easier and less dangerous way to find the height of a building. Today, you'll see how you can use what you know about similar triangles to estimate heights and distances that are difficult or impossible to measure directly. If an object is outdoors, you can use shadows to help estimate its height. The diagram on the next slide illustrates how the method works. So here is the shadow method. The shadow method works when it's a sunny day. An object will cast a shadow. If you hold a meter stick perpendicular to the ground, it will also cast a shadow. The diagram below shows two triangles. One is formed by a meter stick, its shadow, and an imaginary line. These two triangles are similar, and that's because of how the sun hits these objects. To find the height of the object, you can measure the length of the two shadows and apply what you know about similar triangles. All you're going to do today is use proportions. Let's look at an example. A 30-foot building casts a shadow that is 75 feet long. A nearby tree casts a shadow that is 35 feet long. How tall is the tree? We can see that the height of the tree and the height of the building correspond. The shadow of the building and the shadow of the tree correspond. We're going to use what we know about similar triangles, since we have two similar triangles, to set up a proportion. I can say 30 is to 75 as h is to 35. We can now set up a proportion to solve for h, which will give us the height of the tree. We're going to cross multiply. 30 times 35 is 1,050, which equals 75h. And we're going to divide both sides by 75. H equals 14 feet. We need to remember a label this time, as we have labels. Now, this isn't the only way to set up the proportion. You could have done 30 over h equals 75 over 35, as long as you're consistent in setting up your proportion. A stick 2 meters long casts a shadow of ½ meters long. At the same time, the Washington Monument casts a shadow 42 and 45 hundredths meters long. How tall is the Washington Monument? It's really, really important in these problems that you have pictures, okay, or triangles. We are given pictures in this, but we want to make sure that we set up the pictures with the information from the problem. So I know that the meter stick has a shadow that is 0.5 meters long. I know that the shadow of the Washington Monument is 42 and 45 hundredths meters long. I don't know how tall, so we're trying to solve for x. From here, we can set up a proportion. Go ahead and pause the video, try setting up your proportion, solving, and seeing if you get the correct answer. When you're ready to check, press play. I gave one example of how to set up a proportion. Make sure you show me your cross multiplication, and you should have gotten an answer of 169 and 8/10 meters. Don't forget your label. A 24-foot building casts a shadow that is 8 feet long. A nearby tree casts a shadow that is 3 feet long. How tall is the tree? Before you can do anything, you have to draw pictures. There's no picture given in this one. Make sure once you've drawn the picture that you add in the labels. It's okay to just use triangles. If you would like to add in some more images, that's fine as well. Once you've drawn your picture, you want to set up a proportion and solve. Go ahead and try this one. So pause the video. If you need a hint as to how to draw the pictures, watch a little bit further and you'll see the pictures, but then really make sure that you are trying this one on your own. Here's how I set up my pictures. I have my building, its shadow, I have the tree and its shadow. If you haven't set up your proportion yet, please pause the video, set up a proportion and solve. The tree is 9 feet tall. Another method is called the mirror method, and this works when we don't necessarily have the ability to be outside on a sunny day. So an alternative is this mirror method, and it helps you to estimate heights. The mirror method works indoors and outdoors. The mirror method is shown below. What you do is you place a mirror on a level spot at a convenient distance from the object. Then you, as the person, will back up from the mirror until you can see the top of the object in the center of the mirror. The two triangles in the diagram become similar, and to find the object's height, you need to measure 3 distances and use similar triangles. So let's look at an example of Joan who used this mirror method. Joan used a mirror to estimate the height of a flagpole. Below are the measurements she recorded. What is the height of the flagpole? So we can see the height from the ground to Joan's eyes is 5 feet. The distance from the center of the mirror to Joan is 2 feet. The distance from the center of the mirror to the flagpole is 9 feet. We need to identify how tall the flagpole is. And as you look at these, we have 2 similar triangles. All we're going to do is set up a proportion. So I can say Joan's height is 5, so 5 is to 2, as the flagpole, let's call it F, is to 9. All I need to do now is cross multiply. 5 times 9 equals 2 times F. 45 equals 2F. Set up a balance and divide both sides by 2. F equals 22.5 feet. Here's another example of indirect measurement. Darnell, Angie, and Trevor are at a park along the Red Cedar River with their class. They decide to use similar triangles to find the distance across the river. After making several measurements, they sketch a graph. Here is the diagram. We need to make sure that we redraw our 2 triangles first before we go to set up a proportion. So I can see, looking at this, I have a big triangle here, but then I also have a smaller triangle. So I need to set up my 2 triangles and enter in the information in order to solve. I can see that I don't know this entire length. I could just call that whole thing X. I know that across the top it's 160 feet. On the small, I know this is 120 and this is 80. This is just one way to solve. There are definitely other ways to solve. Here I can then set up my proportion. X is to 160 as 120 is to 80. Cross multiply, I get 80x equals 19,200. Divide both sides by 80. X equals 240. Now, is 240 the actual answer? 240 represents this entire length, which is this whole length. The directions want to know how far across the river it is, which is just this space. All I have to do is then take away this 120. and I get an answer of 120 feet. You can use this idea of indirect measurement to find many different distances that are hard to find otherwise. You are at an indoor climbing wall. To estimate the height of the wall, you place a mirror on the floor 85 feet from the base of the wall. Then you walk backward until you can see the top of the wall centered in the mirror. You are 6.5 feet from the mirror and your eyes are 5 feet above the ground. Use similar triangles to estimate the height of the wall. Make sure you show your work. Press pause to try this one on your own. Then press play to check your answer. You should have gotten 65 and 38/100 feet. Make sure you set up your proportion and showed all of your work. At this point, you're ready for your closure, which is in Class Kick. Go ahead and complete the closure in Class Kick. Make sure you use the selector tool to enter your answers. When you're done with your Class Kick, then you're working on your worksheet number 12. Make sure you complete, show your work, correct it, and Dropbox it before your next class.